Okay, are you ready to start with part 2, number 1 on the Unit 3 performance task? It states that the congruency of triangle MNO and triangle XYZ can be proven using a reflection across a line bisecting OZ. However, this congruency can also be proven using geometric postulates. Theorems and definitions. Prove the triangles are congruent using a 2-column proof and a triangle congruency theorems. So I am given that measure of angle M is congruent to angle X. So you should always get into the habit of marking those angles on the diagram. And it's also given that angle N is congruent to angle Y. So this time I'll use 2 arcs. And segment YZ is congruent to NZ. YO is congruent to NZ. So just this little part right here. And NZ is this part right here. Remember, we have the whole side of each triangle. Okay. So this is one side. And then this is the other side of the left triangle. Do you notice how they share ZO? So ZO can be congruent to itself by the reflexive property. All right, let's start the proof. Now I will need to scroll up. Before we move on, actually, let's take a look at the triangle. Picture the right triangle. And let me draw that separate. That's always helpful. So let's say I draw this right triangle, and it's going to be a smaller version just because it fits nicely that way. So I'm going to label this vertex Y. I'm going to label the bottom left vertex Z. And then the top vertex, I'm going to label X. Okay. Now, let me go ahead and mark the figure as I did a few minutes ago. So Y has 2 arcs. YO, which is, I'll have to put point O right here. Okay, and then I have X congruent to M, so I'll put an arc right here. Okay. So now the proof statement asks us to prove triangles congruent. And recall, in order to prove triangles congruent, you can do it one of 5 ways. You can do the side, side, side. You can do the side, the angle, side, angle, the side, angle, angle, and hypotenuse leg. So here's the plan. Seeing how OZ is shared by both triangles, okay, this part right here, okay, we can say that OZ is congruent to itself by the reflexive property. Then we can say that YO plus OZ equals the whole segment YZ. And that's the segment addition postulate. Then we can do the same thing with the triangle on the left. We can say NZ plus OZ equals the entire segment NO. Okay? And that would be a pair of sides in the right and the left congruent. Not just a portion of the side. I'm not talking just YO and NZ. That's not a whole side. That's not the entire length of the bottom segment. You have to add OZ, and that's why we're doing it, so we can get a pair of sides congruent. So if we get a pair of sides here, a pair of angles here, and then a pair of angles up here, which of the 5 congruence postulates that I've written up here do you think would prove these triangles congruent? Well, we certainly don't have side, side, side. And since we have 2 pairs of angles, side angle side is only 1 pair. It's not that. It could be angle side angle or side angle angle. It's definitely not hypotenuse leg. We don't have a hypotenuse. Hypotenuses are for right triangles. So it's either angle side angle and side angle angle. It's either the included side or non-included side. Now let's talk about that for a minute. The included side is the side shared by both angles. So if you look at angle X and Y, they share side YX. So the included side would be YX. Look at the left triangle, okay? Angle M and angle M. Angle M has one side here and has the same side in common. That is the included side. However, we're given no information about MN and XY at all. So it's not going to be angle side angle. It's not going to be the included angle. So we're going to shoot for side angle angle. And the reason being is the side is not the side that's shared by both angles. For example, if you look at this triangle here, we have an angle, and then this side YZ will be congruent to segment NO. So it would be side, angle, angle. It's not the included side for both angles. It's not YX as the side that'll be congruent. That's the shared side of both angles. So if it's going to be YZ congruent to NO, then it's going to be side, angle, angle. Okay? All right. So now I'm going to have to slide this so everything's going to move with me. So I'm going to have to erase much of what I've done here. Okay? But you can rewind this video and re-listen. So the first 3 statements, you always have to go back up to the given. M is congruent to X, N is congruent to Y, segment YO is congruent to NZ. The first 3 segments are all given. So I'm going to write given for each of those. Okay. YO is equal to NZ in statement 4. But you look at the previous statement. Whenever you're at a statement in a proof, you always look at the one before it or more than one statement before it. But this directly makes a connection with statement 3. So if I say 2 segments are congruent, you would say they're the same length. Well, statement 4 says YO equals NZ. And with that is read as the length of YO equals the length of NZ. And how do we know that? How can we draw that conclusion? Because of the definition of congruence, okay? All right. Now, remember we talked about OZ as being the common part of the bottom side for both triangles? So, with that being said, OZ is shared, so we do the reflexive property. OZ is equal to ZO, A segment is congruent to itself by the reflexive property, so that's going to be the reflexive property. Let me change colors. Okay. Now, let's take a look at statement 6. It does say that YO plus OZ. Remember I talked about segment addition? We're adding YO's length to OZ's length, and we get the total length. The sum of the parts equals the whole. One part is YO, the other is OZ. Add those two lengths together, you get the total length of YZ. And you can do it for the fit triangle on the left. NZ is one part of NO. OZ is the second length. If you add the length of OZ and NZ, you get the whole length NO. Okay? So that is, now in statement 6, if you notice they're adding ZO to both sides. When you're solving an algebraic equation and you're trying to solve for X and you add a number to both sides, that is called the addition property of equality. So since we're adding OZ to both sides, I'm going to call that the addition property. All right, some of you might call it the additive property. Now statement 7 takes the sum of YZ and NO. So, I'm sorry, YZ and OZ. So if you add YO and OZ, that's YZ, right? And if you add on the right NZ plus OZ, and you will get NO, the total length. So that's the segment addition postulate. You can add the lengths together to get the whole. So that's segment addition. Okay. Lastly, kind of like statement 3 and 4. Statement 3 says the segments are congruent. Statement 4 says they're equal by the definition of congruence. Statement 7, it's in reverse, says YZ is congruent to NO. I'm sorry, equal to NO. And YZ is congruent to NO. Okay, if I say two segments are equal in length, like in step 7, in step 8, I can say they're congruent because of the definition of congruence. And then we discussed triangle MNO congruent to triangle XYZ already by one of the triangle congruence postulates. Which one is it? Side, 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 angle, side, angle, side, angle, angle, side, angle, side, or hypotenuse leg. I'll leave that up to you. All right, that is the end of part 2, problem 1. I'm going to stop the recording and I will make a new recording for the last problem on this performance task.